Hi guys, so it's week 2. First I'm going to go over what is due at the end of this week. We have week 2 forum as well as chapter 3 forum 5 homework and test on MindTap, which is under week 2, and the part 1 of the drug project, which is under assignments tab in Sakai. If you have any questions on the drug project, please reach out to me now before Saturday so that we can get that taken care of so that you're not rushing at the last minute to get it done. We're covering chapters 3, 4, and 5 this week. Chapter 3 starts with sources of drugs. It differentiates between where drugs might come from, and the 4 places that they talk about are plants, animals, minerals from the soil and the earth, and finally synthetic manufacturing of drugs, or man-made, meaning they don't come from any source. We actually created them within a lab. Next, the book follows, talks about effects of drugs, systemic versus local. Systemic is meaning the entire body. The body, no matter where the drug enters, it ends up being distributed to the entire body. A local effect is more one place. For example, when you put on, let's say you had a bee sting and you put something on top of it, that is local. It stays right there. It's only working right there. It doesn't end up being distributed and working in the whole body. Speaking of distribution, the book also talks about what we like to call in pharmacy world is ADME, A-D-M-E. That is on page 28 is where it starts. Within the body, drugs undergo several changes, and it's right under there. So ADME is absorption, distribution, metabolism, and excretion. And it's basically just the path that the drug follows as it is, whether it's swallowed or injected. So absorption. When a drug is swallowed, it ends up in the stomach and has to go through a process where it is broken down and then absorbed into the bloodstream. Distribution. From there, the bloodstream distributes it whether selectively to certain parts of the body or all over the place, and that's dependent on the properties of the drug. Metabolism generally happens in the liver, and that's where the drug is broken down. Maybe the medication is what's called a prodrug. It's not active until it's metabolized. Or maybe the medication is metabolized and broken down into different parts, and some of those parts are toxic. So metabolism is really important because it can affect either how the drug acts or if it harms the body. Finally, excretion. Excretion can happen through a number of ways, whether the minor ones are sweat, lungs, through exhaling, through our bile, but the major way that excretion really happens is through the kidneys. So as you see, those last two are dependent on major organs, liver and kidneys. If you have liver or kidney disease, the process of metabolism and excretion can be slower, which means that drug might build up in the body, which can be a bad thing. So those are two very important parts of the ADME process that we really like to pay attention to. And a lot of times, if a drug dose is adjusted, it's based on perhaps the patient has liver disease or kidney disease. Other variables that can affect how a drug acts in a body, there's 3: age, weight, and gender. Age, an elderly person might not process a medication as fast as a person of our age or younger. They generally have slower metabolism, as well as they might have kidney or liver disease, which could end up affecting how the drug is processed. Now, on the other extreme of that would be children. So they can have unexpected reactions to medication. So a lot of times the most important thing to do with them is monitor. Weight. You always think if you're higher weight, you need a higher dose, which isn't necessarily always true. It can be true to a point, but sometimes you have to take into account what the person's ideal body weight is, which is what you would expect a person of their height to weigh. It helps more keep doses under control with somebody who is morbidly obese or could run into problems if the drug is toxic at too high of a dose. Finally, gender. Women and men, women tend to have a little bit of a slower metabolism as well as higher body fat percentage, which can affect how the drug is distributed, where it's stored, where it ends up. So we just have to be careful sometimes in that case. The book goes on to talk about interactions. Actually, that is on page, where'd it go? Drug interactions. You might have heard the word interactions referred to. Sorry, that starts on page 33. You might have heard a lot of people talk about, oh, my medication interacted with such and such. Usually that's in a negative form. Like, you don't always want an interaction between a medication once it reaches the patient, so that they have to be taken off of it. So we're going to start with synergism, potentiation, and antagonism. Synergism is when two drugs work together. They're both working together to make themselves better. Potentiation is when one drug increases the effect of another. And antagonism, just like it sounds, is when they work separate apart. They actually, one can decrease the effect of another. So there can be desirable or undesirable. The book covers each of those, and I would recommend that you just kind of get a little familiar with what they each mean. Desirable meaning it's something that's good, such as desirable synergism, when we combine two medications so that it better helps the patient, whether it means that, let me see what the book talks about. For example, they give an example of a cholesterol synergism. Two different cholesterol medications, but by giving small amounts of both of them, you're bringing the cholesterol down more than you would if you had one of it or the other. Undesirable synergism is, they give an example of sedatives and barbiturates, which can decrease the respiratory response so much that the patient is not breathing enough to get enough oxygen to the brain. Desirable potentiation, to build up a high level of some form of penicillins in the blood. The drug probenecid is given sometimes, so probenecid helps penicillin get to a higher level. Undesirable potentiation, this is a lot of the interactions that we hear about. You know, drug A causes drug B not to be metabolized, so drug B ends up building up. So that's undesirable. It's not always what we want. Sometimes we have to adjust the dose of drug B in order to not have it build up too much, or we'll just completely get rid of drug A. Antagonism. Desirable. You guys may have heard about this actually recently a lot. Naloxone or Narcan can reverse opiate overdoses within a second. You push the medication in and the patient all of a sudden comes out of their overdose and they are wide awake. Desirable for us because it means that you might be saving someone from possibly damage or death from an overdose. Not desirable to the person you're giving it to because they were happy in their current state. So that's what they mean by that one. Okay. Next, the book moves on to dosage and talks about minimum dosage, maximum dosage, loading dose, maintenance dose, toxic and lethal doses, as well as therapeutic. Those are all exactly what they sound like. Minimum meaning minimum effective, maximum meaning where you're not going to see any more improvement beyond that dose. A loading dose is a dose that they'll give somebody to get them up to a certain point. For example, it will be a higher dose and they'll take that and that gets their levels in their body up to where they need to be, but that's not the dose they're going to be on to sustain that level. That's called the maintenance dose, usually lower, and it keeps them at that level. Toxic and lethal doses. Toxic will make you sick, lethal will kill you. So that's the difference between those two. Therapeutic dose is where it is active. You have your min and your max, and right in the middle of that is where dose is therapeutic. Next we move on to routes of administration. They're separated into two. Anything that's by mouth is called enteral or GI. Everything else is called parenteral. So enteral or GI can be, I said anything by mouth. We don't very commonly use the rectal route as much as we do the oral route. So anything that's ending up in the GI tract. And then parenteral would be your IV, IM, sub-Q, intradermal, topical, etc. Anything that's going to be not by mouth or not rectally. Okay. There are advantages and disadvantages covered on page 37. I would recommend taking a look at those so you can kind of get familiar with why the oral route might be advantageous over the IV route or vice versa. Okay, so the book covers adverse drug reactions, which is an unintended action, and that's that long list of things that happen when you take a medication that aren't necessarily the intended action, such as drowsiness or nauseousness or headaches. it talks too about some pretty serious ones. The teratogenic, meaning that the child, a fetus, will be harmed if the patient takes this medication, whether it's malformations or brain damage. So it covers that, as well as idiosyncratic and paradoxical reactions. Idiosyncratic are unique, unusual, and unexpected reactions to a medication, whereas paradoxical is the opposite from expected. Usually when we talk about paradoxical, we are referring a lot to children. Sometimes when they take a medication, for example, Benadryl, most people it knocks out, it makes them drowsy and tired. However, with children, it can wind them right up and they are hyper and wide awake, so that's what we call a paradoxical reaction. Tolerance is a decreased response due to being used to a medication. You've taken it for a while, maybe you're tolerant to it, and you're no longer having the same side effects that someone would take in the beginning. So next we talk about dependence, and dependence can be two parts. It can be psychological or physical. Psychological is when somebody craves it when they don't have the medication. Nothing necessarily happens to their body. They might not have tremors or sweats or withdrawal symptoms, but in their mind they need that medication. Whereas a physical dependence is what we just talked about, those body signs that tell you that the body is without the medication. A lot of times you're probably most common with withdrawal from illegal substances. A patient is having tremors or sweats, or you can tell that their body needs that drug in order to get back to a state of calm. Lastly would be a hypersensitivity or allergic reaction, and there are differences. What we call a hypersensitivity might be mild, the patient breaks out in a rash, or the patient just doesn't deal well with the medication. Not as serious as an allergic reaction, where the patient might break out in hives or have difficulty breathing, things that would really have us take a second look before we have that patient take that medication.